Okay, so we had just finished graphing all this data from the table, and since the table had a constant, we were able to write this equation, y equals 2x. So beside this line, I want you to write y equals 2x. That is the graph that fits that line. Another thing I want to show you that we'll be using frequently, go ahead and turn your calculator on. Hit the y equals button where you can see this, and we just had the equation y equals 2x, so it already has the y equals typed in, so you're just going to type 2, and then you have to hit this button that's right under the mode key to type in your variable x. Now up here at the very top right, you can hit graph, and it will draw the line, which our graph only shows quadrant 1. So you can see how whenever you graphed it on the calculator, it did go through the origin because it's proportional and it's linear, it's a straight line. Another thing that you can see in this table or on the calculator is if you hit second graph, because up above it, it says table, and yours it would be blue, but mine's yellow. And then you can see this data that we filled into the table, 0, 0, 1, 2, 2, 4, 3, 6. It has all those coordinates that we use to graph it. You can hit second mode, or just turn it off because we're going to start the second one over here. Livy, go turn this water off, please. Okay, scenario 2 says a Fantastic Fair charges $4 to enter and then $1 per ride. Okay, so now it's a little bit different information. Whenever you enter that fair, they're just paying $4, so you're just going to pay that one time. It does not happen over and over. But then this part, $1 per ride, well, that could happen over and over if you were going to ride more than one ride. Okay, so just like the other table, we're going to label the top row X and the bottom row as Y. So now I'm going to use their scenario and I'm going to start filling in this table. So 0 rides would cost, if you think about it, you had to pay $4 to get in. So even if you didn't ride anything, maybe you just walked around and were hanging out, you still had to pay that $4, but I'm not paying for any of these. So 0 rides this time costs $4. 1 ride, so I'm paying that $1 and those 4 to get in. So 4 plus 1 gave me the 5. 2 rides, so there's $2 plus that 4 is 6. 3 rides, they're $1 each, so there's $3 plus the 4 to get in is 7. 4 rides would be $4 plus the 4 to get in. 5 rides, $1 per ride, so there's $5 plus the 4 to get in, so there's 9. Does the table show a proportional relationship? Anytime you are asked this question, you need to think of finding the constant. So write out the equation. Constant equals y divided by x. Now, 4 divided by 0, what do you think that's going to say? It says error because you cannot divide by 0. Like whenever we talked about the undefined line, the run was 0 on the bottom there. Could not divide by 0. So I'm going to skip over that one. I'm going to do this y divided by the x. Okay, so I'm doing 5 divided by 1, which is 5. I want to see if on this next one, whenever I divide it, am I getting a constant answer? 6 divided by 2, well, is 3. So, no, it's not a proportional relationship. There is no constant. Okay, so whenever you divide the bottom by the top and you do not get the same answer over and over and over, there is no constant. It is not a proportional relationship. So there is this equation that goes with non-proportional relationship. It is called slope-intercept form that you're going to hear a lot about this year. I want you to write y equals mx plus b. But before we start filling it in for the m and the b, which I hope you already know, m stands for slopes because a mountain has slopes. We're actually going to graph these. So just like ordered pairs, my first x and y is 0, 4. Remember, we're starting at the origin. That first number tells me about going on the x-axis. We talked about that baby has to crawl on the floor before they can go upstairs or downstairs. So this baby, 0, is not going anywhere, it's staying there. But then at 4, I'm going to go up 4 and put my point. So notice, this line ain't going to go through the origin, it's starting up here. It's not starting down here like proportional does. We said it's not proportional. Okay, my next point said 1, 5. So from the origin, I'm going right 1 and up 5. My next set of coordinates from the table said 2 and 6 for the x and the y. I'm starting from the origin. I'm going right 2 and up 6. I have 3, 7. From the origin, right 3 and up 7. Okay, I've got 4, 8. You can pretty much tell where the next points are going to go. Oh, my last one, 5, 9. Okay, just a minute. Go ahead and draw a line through your points. Okay, remember that M was for slope, so I can pick any 2 points that I want to and count the rise over run. On this graph, my rise is 1 and my run is 1, so that just reduces to a 1. So I'm going to go ahead and fill in a 1 for my M. Bring down the y, the equals, and you have to keep the x in there too. Now this b back here is new. I haven't talked about him yet, so I hope you're listening. B stands for, and we can kind of write this out here,